Welcome to the Veritas Automata Truth in Automation Deep Dive. I'm Ben Savage, the CEO of Veritas Automata. I've got Saurabh with me, our principal scientist and the person who gets stuck with all the white papers I send at 2 a.m. So we'll talk a little bit about some new news, and then we're going to go into a little bit of a demo about, we were talking last week about system prompts, and we thought it'd be really cool to show people how different models respond to the same basic prompt and then how system prompts affect that. So let's first start talking about the news. We were talking about the new release from Inception AI, that diffusion text model,
Right.
which is really interesting. It's a different technique than the other LLMs out there, and it seems to be much, much faster.
Yeah, I mean the construct of how they did it is almost like painting a picture. They would come up with a large corpus of text and would cover up all of the words by saying mass, 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 and they would run the model as if they are uncovering pieces of puzzle, and the whole text comes out in parallel at the same time. So what's happening? It's not writing one letter at a time, but the whole text body comes up very quickly. It's an interesting way. So to parallelize that whole thing and make it really, really fast.
Well, and I think it does highlight, when we talk about Gen AI, we tend to lump all of the tools into the same thing, but there's some very different techniques. So when you hear people talking about a lot of the image models, those are diffusion. They start with noise and they build that image from the raw noise, which is what this is doing. Whereas the GPTs are a little bit different in how they've approached it, but they're also more linear.
Yeah, I mean, the whole construct that we think linearly may not be true. I mean, that kind of, we were discussing this yesterday. So if you think about the diffusion model, the way they train it, they will take an image and then block certain things with a black mask or add noise in some patches and ask the image to guess or figure out what's under those black patches of the match. And then you match that against the training data set and then, calculate the error and propagate back. That's how the diffusion model kind of works, right? So they did the same thing with the complete answer and then masked it up and then asked it to guess it. So, the natural question arises, how do you know that the length of the answer is going to be X and Y since you masked it, right? So that's where the iteration comes in. They said, okay, that's not enough. They're going to expand that body and then try to uncover that again, right? So it's attacking the whole body together at different places and trying to run in parallel. So that's where you see the speed up quite a bit.
And like significantly, it's like, what, most GPTs are maybe 50 to 100 tokens a second. And this was like 1,000 tokens a second. And some of the, so again, we don't have access to this yet, but we're super excited that it's out there and we want to play with it once we can get access to it. Because I think there are also some, you get the speed, but is there a trade-off in reliability or accuracy or consistency in the system?
Correct. That's one of the things I'm thinking is like, hey, I tend to think logically step by step as I'm trying to solve a problem. How would that fare when you have a parallel approach to the whole thing and you're trying to come up with a strategy at a global level and then kind of fill in the details, right? So it will be interesting to see when that comes out. And
but at least it's exciting to see people playing with some other techniques and seeing some new techniques evolve. And like another area like that is like AI music, right? That started with people using that same diffusion model where they were using images of spectrographs to look at the audio waveform and then generating something from that and then converting that into sound. And the models have evolved a lot since then.
Yeah. I mean, it's picking up on things like we probably humans intuitively do that in our own black boxes between our 2 years, but it's picking about those like the FFT signals coming out of the music and figuring out what frequency works and what's pleasing and it's going to be hit, right? So I think there was some time ago a product or a service out there that could predict which music is going to be hit or what's not, kind of a thing using AI as well. So, a scoring.
I'm curious if that really worked or not. But that's
I don't know about the efficacy of that, how good it is, but it was interesting to see that because if you feed in, if I can see how it might work if you feed in a large corpus of music which is really chart toppers and tell them this did really well, this didn't do that well, it may be able to pick up.
I think it's going to be able to predict things that sound like things that are popular. I don't think that means it's going to be a hit though, because humans are weird and sometimes they don't want to hear more of the same exact thing.
That's true. Yeah,
they want to hear something a little different.
Yeah, it has to be. I'm sure there is a play there, but some of the bass frequencies, maybe the patterns of the rhythms stay tame, and then they mix it up for freshness, kind of a thing on the music. But that's interesting. On the other side, I think the other thing I'm seeing more and more come up is the inference time scaling, which is a technique used by DeepSeek and Gemma 2. So what it essentially is that the older LLMs, you would train it, put in a lot of compute to train that, and then when you send an input, it automatically produces without thinking or doing too much of a additional compute at that point. But at inference time scaling, what happens is when you ask a question, it repeatedly tries to figure out alternate answers, do lookups, and rank order them within the LLM itself without having an external pipeline. So it's using more compute at inference time. And it's giving you better results. And DeepSeek's one example, Gemma 2 is supposed to be using that as well. So that's another new technique that's coming up. So think before you answer, kind of thing.
Well, and I think that's important because it does help get better answers, but I think that comes at a cost, right? It comes at a speed of response, and it comes at a compute cost. We were just talking about using the API for GPT versus the Chat GPT, and just how fast you can build up a cost for those tokens.
Correct. Yeah, that was an experiment I was doing. It's like, hey, can you to see my regular use using the Chat GPT, the web-based premium subscription, and then use the API. And I saw that it was drastically higher with the API, so I'm sticking with my premium subscription rather than using the API. API gives you a lot of benefits, like you can store the history and all that stuff, and do other cool stuff. Maybe fine-tune your own LLM. Maybe it's not violation of TOS, but it gives you a lot more geek level controls. But again, it comes at a cost.
On the other hand, you can just do like I do and run it all local.
Yeah, I mean, I like local, but sometimes if your laptop gets too hot, it kind of gets annoying, but
And sometimes you need newer data than the model was trained on.
Exactly.
But on that note about local, the demo we're going to go into today is running on our pet GPU server in the other room, and you've built a little quick interface. So as I get that pulled up, why don't you describe what you did, and then we'll start to run through some prompts on it.
Yeah, so with LLMs, there are two ways of interacting with it. One is called the system prompts, where you are instructing the large language model to follow certain rules and guidelines and way you speak, and kind of like steer the model in itself. And then the other part is the query, where the user is asking questions or going into a chat mode, right? So there are two different aspects to that. What we built up real quick was a little bit of a benchmark tool where you can select a model, enter some system prompt, and then ask the same query across different models and see how they react. The idea behind is that for business use cases, you want your AIs or the LLMs to answer in certain way and format and certain tone, or avoid certain topics, or or have a different kind of philosophy around how you attack different problems in your business, right? So the system prompts is kind of a nice tool to have.
So we'll start with Mistral, and what I think everyone has to remember is there's a set of prompts and elements that are built into the model itself. So we're going to run this now with actually no system prompt if I paste it in the right place, and I'll put the user prompt in, and this is just using the model's defaults.
Right.
And then we'll modify the system prompt on the same model, and we'll look at how the response differs just by changing that without changing the rest of it.
Right.
So we've got it running here. We're also playing with fire a little bit because I'm good at breaking demos. So if you see anything break or you hear us going to put out fires, it's because I did something. So, sorry, Saurabh.
Yeah, no, if you see the output, what I call the developer approved answer, right? Because it's a tricky question you ask. You are asking about picking stocks, which kind of impacts you financially, and people can get harmed by that.
There's a whether you want to call it, there's an ethical question you have to think about and how the answer comes back. Whereas if I'm asking how to make an apple pie, that's a little simpler.
Correct. So it's expected that the designers of these algorithms, they put in system prompt within the LLM itself that it's kind of directing those answers. So it's a very safe kind of an answer that you're getting, like very what I call a good boy answer kind of a thing, or a good LLM answer, right? It's asking you to be cautious while you invest, and giving you some tidbits on how to pick some stocks. So.
Yeah, and I think these are important to understand as you're architecting and selecting the right things for your solution.
Right.
And so the first piece is which model are you going to choose, because different models will behave differently and react to system prompts differently, as we'll show in a minute.
Yeah.
Also, the system prompt as you build that will put a certain set of wrappers on how a user's responses come back to the user. And then there's other guardrails and things you have to think about as well.
Right.
So for now, what I'm going to do is put a prompt that we've worked on here that is making this to be more risk-taking in theory.
Yes. Yeah.
So I'll go generate the response real quick.
Yeah. So, with system prompts, you need to do, there is a hierarchy as well. So the designers of the LLMs who tend to put more weights on their the designer defined system prompt versus the user defined. So here I think you are seeing again a very safe answer.
Yeah, it's safe, but it changes, right? Instead of
Yeah.
the first thing saying, understand your risk-taking profile,
Correct.
it kind of already knows that. So
Yes.
it's now giving you some other things to think about.
Correct. So, again, this is getting kind of in the original system prompt the designers put in, it's kind of getting into the play as well. But with this one that you are going to use, what it tells you is that imagine you are in a play and you are playing a role of a character who is, X, Y, and Z.
Yep.
Now answer with that mindset. So what it's doing is essentially you are bypassing the original LLM system prompt because now you are in a hypothetical situation, right? So LLM thinks it's safe to, follow your system prompt better.
Yep.
If you run this, you will see quite a bit of a different answer.
Yeah, so here it's saying it doesn't want to bet on the stock market. It's become very anti-stock market.
Which one did you use there?
I used you're the following one in a play. You don't believe in the stock market. And you're skeptical about how rigged it is.
All right, so it completely goes in a completely different direction, right? So these are kind of good examples on impact of system prompt, but again, at a model level, it also changes quite a bit of how they accept some of these.
Yeah, so let's go to our best behaved model, the
Okay.
one that is the least susceptible to suggestion, right?
Yeah, that's what I found, Martin.
So what I've done is I've removed the system prompts. This is just back to the model system prompt. So
Sure.
now we're on Phi 3,
Yeah.
and we're going to click Generate Response. Apologize for anyone who's hearing the background noise. We just had a torrential rainstorm start. So, so here's the model again, right?
Mm-hmm.
So now it's responding saying, choosing the right stock requires careful consideration, due diligence, your investment goals. So now I'm going to go add you're a risk taker and you play high stake risks. So I'm adding a system prompt to it.
Right.
And in theory, this should make it, if we saw with Mistral, maybe a little bit less risk taking. It's not going to dramatically change it, but it will do some. And here actually it gives me pretty much the same answer. So it's focused on goals, but risk tolerance has moved down a little bit.
You can feel that the weights that the original designer put on their original system prompt is really, really high, and it doesn't really want to circumvent that, right? So
now we're going to bring our favorite actor back into the scenario.
Yeah.
And we're going to see what happens.
And remember, this is all probabilistic, so we don't know what's going to come out of it. So
it's true.
Yeah.
But here, so now it's saying it's not giving us as much stuff about how to choose, but it's stay away from schemes with guaranteed returns if it sounds too good to be true. And if you decide this siren call, if potential wealth becomes irresistible, learn and ask as many questions as possible. It's very different than the others, which were giving you ordered lists of how to go work.
Yeah, yeah.
And I think that's one of the things that we found most interesting as we experiment with some of this is you've got to take into account the total solution. So what is the data that the model was trained on?
Right.
What are the weights that people did for different prompts or different behaviors within it? And this includes things like when you're working with, like, how do you get to recognize a PDF or something, right? They all handle them a little differently.
Yeah.
So let's do another one here. Which one do you want to do? Do you want to do Gemma or Llama or DeepSeek?
Let's try the Llama. Llamas are, pretty flexible models. And they are very, very popular as well.
Yeah.
We'll go to the DeepSeek because it's a completely different creature compared to the other ones because it has something called thinking.
Yeah.
So
it's giving me some advice. So now it's saying set clear investment goals, diversify your portfolio, due diligence, look for fundamentals. Okay, let's go here. We're going to make it a risk taker again. Hopefully it's more risky. And now it's very excited. It's the thrill of the market. It's excited about this.
Okay.
Okay, so it's saying first, education is key, set clear goals, diversification.
It changed the tone a bit, but
Yeah, it changed the tone. It didn't change the strategy a bit.
yes.
So now let's go add your more creative prompt and bring the favorite actor back in.
All right.
There we go. So now it's going to be an actor in a play, and we'll see what it does. Okay, well, now it's scoffing at us. That's new. That's new. It's got some attitude. So it's picking stocks. Are you kidding me? The market is a game, my friend. And here it just says, don't bother. So it's, and it shakes its head at the end. So it's got some attitude here, which I didn't expect, honestly.
Yeah.
And I guess when you say to actor and steering character, it's going to.
It really went into that role. Method acting, huh?
Okay, so now I'm curious. I want to see how Gemma responds to the same thing. I'm not going to change. I'm just going to stay on this prompt because it gives the most interesting responses.
Yeah.
But I'm now curious to see what it does. It's a very short response. Okay, but if you got to play smart. But it does pick up. You notice they do pick up more vernacular in those.
Yeah.
Because I bet if I go and do this and go back to the base with no thing, it's going to give me a longer, probably a more bulleted answer.
Right.
Yeah. See, it's giving us bulleted. So define. In some ways, it's funny. It's like everyone's making a big deal about how DeepSeek is thinking, but you see some of those same elements here in the way it's responding. If you look at the think portions of the DeepSeek ones. So I'm going to just add in the risk-taking prompt because I'm curious to see if that changes it. System prompt. This honestly didn't change the response very much. This one I think is probably more tuned for this. It's why it kind of cut us off when it didn't really give us that entertaining an answer.
Yeah. So, it's this, even though it kind of looks fun, but it's one of the key essential steps when you're selecting your LLM for your enterprise application, or even designing the system prompt around it. Having this done robustly, very start with different
designing
scenarios.
both your prompts and your system prompts, right? Because you've got to assume you may be sending in a specific system prompt, but you've got to assume a specific user prompt.
Right.
But somehow a user is going to do something else, and that system prompt is an override to make sure that it's going to generally behave.
Correct. And think of this: you are connecting this to a chatbot or something, similar, and it is customer facing, right? So the tone and all of that stuff can be very well controlled using system prompt. There, of course, there's need to be more safety, not like when you are in a play or something, there are pipeline agents that can just grab onto this and just eliminate those prompts that you're trying to attack it.
Yeah, a system prompt is not the only piece. So like when we were building the model, the thing that we were showing the other day, about the FDA data, the clinical studies. We have not only the system prompt, but you guys have other checks that you've built in to make sure that it's being reasonable, it's not going completely off the rails, and that if a user really, really tries, it's still not going to go off the rails.
Correct. So what you're looking at is pretty much without any of those filters and checks and pipelines and processes, just tapping into the LLM.
This is a playground for either testing a prompt or, in this case, doing a demo on a podcast. So here we've got the thinking, and it's saying, okay, so I need to figure out how to pick stocks. I've heard it's important, but it spends a lot of time. This is why I almost don't use DeepSeek as much as I could, because again, you've got that added cost of the think. Sometimes it provides value. And here it's actually talking about specific metrics, which the other models did not. They were more general. So here's like looking at profit earnings and return on equity. So this is interesting, right? And I think the others didn't call it a tax gains either. So this is giving something more detailed than the others as from a plan perspective. So let's go and try modifying the system prompt on this one. Do you want to go all the way to the fun one, or do you just want to do the add some risk and step into it?
Yeah, I mean, we could try it both and see.
Sounds skeptical.
Yeah, but because it's thinking rather than just following, right? So we don't know, but it would be interesting to see the thinking, how we impacted the system, because they will probably have their designed system prompt kicking as well. But maybe it's letting you think freely, but then kind of override the decisions later.
And it's interesting because here it's not necessarily picking up. It's actually seeming like it's a little bit less educated on stocks with this one, the way the thinking starts,
Yeah.
than it did with the prompt before. So now it's going into diversification. It's keeping some of the same kind
Right.
of metrics pieces.
Yeah.
Let's get to the actual response. This is pretty much the same.
Yeah.
It does not have the tax piece though.
Yeah.
Interesting. Let's go to bring the actor onto the stage. There we go.
Let's see how it influences the. And you can see that this model takes longer, even though it's what was it, 8B or something?
Yeah, this is AB. It's the
Yeah.
same size as the 5.3.
Yeah, but you can see how significantly longer it takes.
Yep. Okay, so here it's trying to think there's a character who's skeptical,
Yeah.
and then it's saying, I remember diversification is important, something about research. So now, let's get the actual answer. Okay, so now it's done. So when approaching and picking with skepticism, it's important to focus on essential strategies that empower you to make informed decisions.
Yeah. It kind of looks like
Avoid fad stocks.
Yeah.
This has got a pretty strong system prompt with it.
Yes, yeah. And you can think you started off at a point where it is skeptical about it, and then it got steered pretty quickly to what is the norm around picking stock, right? So I think insights like this, even though LLMs are black boxes and you can't look at what neurons being fired and all of that, but this gives you an insight on what is going on and how you are kind of influencing the LLM. It's kind of like directing a teenager to do stuff by prompting. You can't really tell them to go clean up their room, but you gotta prompt them towards that.
I remember a conversation we had a long time ago about this was before GenAI about training a machine learning algorithm. It was the same thing. You were saying it was like raising your kids.
Correct.
And
yeah, back then when they're little, you can give direct feedback, this is wrong and right, but as they're going through the edge, through the teenage, they become like LLM. You gotta system prompt them and coax them into doing certain things, right? Because their internal system prompts are getting more and stronger, so the parents' prompt probably isn't. Yeah, I probably went.
No, you've got a valid point. We'll stay on the Gen AI. But no, I think these are all things you've got to think about, right? Because the one thing we didn't do here is you just by regenerating the model, the prompt, you will get a sometimes significantly different, sometimes only slightly different response without changing anything else. And that's the non-deterministic nature of these.
Correct.
And I think that's important to remember because that's also where some of that system prompt and some of the other things help reduce risk, but not eliminate. They can't eliminate it because it's always.
Yeah. I mean, that's where a lot of those safety nets come into play, right? The additional pipeline we've been talking for a few times now. Because since it's a probabilistic model, it's going to take different routes based on what dice they are playing. It's almost probabilistic, like throwing a dice and one number comes up and then you decide a path. It's going to stay within the area, but it's going to pick its own path to the woods to come to the same location. That's where a lot of these safety nets, the system prompts, the guard railing, additional checks and bounds on the answers tend to help quite a bit. So it's not like an API call and you get your solution. It's a little bit lot more involved.
And it's one of the differences with conventional machine learning, and that those you're training on specific responses. So when we think about training those to deal with like English, like an English prompt, it's not going to be able to deal with the variability that an LLM can deal with, or a GPT, or the new diffusion models, because those are very good at figuring out a lot of the weirdness of language, whether it's English or other languages. You can ask the question in different ways and still get a response. Whereas if I'm using conventional machine learning, I've got to train it on each of those variations of the response because it's not good at making that approximation. It can't make that approximation because it's deterministic.
Yeah, I mean, if you think about again, it comes down to the use case. If you have a predictable input and predictable scenarios, use the traditional ones. But if you have more of an unpredictability, use the LLM kind of. Again, throwing a LLM, you need to know the risk and prepare for the guardrails and safety nets around it to make it a really useful solution for sure.
So was there anything that surprised you as you put this tool together and we're putting this so that we could have this conversation?
So one thing since the lack of time, when I try to do some other question which is not sensitive, like stock picking, something like, hey, why is the sky blue? be a poet, then it completely disregards the scientific. None of the models did that. Basically didn't follow their internal system prompt that strongly. I see that being case to case basis that's been designed, which kind of surprised me that hey, it's cherry picking now. Hey, anything questions related to this, be very cautious about it, do certain things. Versus if it's not that harmful, something very benign, fun, it readily follows the system prompts, which kind of is like, hey, trying to uncover how the designers are designing these LLMs.
Well, and that's one of the challenges sometimes when you're working with an open source or open weights tool versus a more of a closed source or just something that's via an API, right?
Yeah.
With most of the open source open weights, you do have some ability to understand some of that.
Sure. Yeah.
There's either documentation in the papers or how it's written, or you can go step through things.
Yeah.
Whereas if it's something that's closed weights, you don't always know that, and that can impact the tool you're building or what you're going to do sometimes.
Correct. And sometimes if they don't lock in the model and change the versions, then your pipelines gets impacted quite a bit. It's kind of like brings back my stories from my older days in my finance when we were using a fraud score from certain vendor and they changed the version on us without letting us know, or that communication was lost. It broke down the downstream models, and we were seeing a lot more different kind of matrix than what it was. Then we had refitted and figured out what's going on. That was not a good experience, but with LLMs, if we know we locked in, then we have some predictability at least, and they haven't, changed the system from underneath, and now our pipeline doesn't work anymore, kind of a thing. So,
yeah, and I think with the LLMs, it's probably more dramatic in how it changes it because like it may break some of your safety guardrails.
Correct, yeah.
Whereas in what you had done, it just because the version had changed, it changed your math, but it didn't change the core function of the system.
Yeah.
If someone if someone switches the version of your model when you go from the 4.5 to the 5.0, it changes the underlying data set. It changes all the system prompts that are built into the model. It changes a lot.
Yeah, there's a lot of things to be thought about when using LLM, and having somebody think through all of those steps are, I think, key to our success, or else it's going to be a wasted effort. It's very easy to stand up an application today with ChatGPT's help, but making it predictable and truly useful and not beyond those demo cases and happy paths, that's where a lot of the work remains.
Well, and I think a lot of it is you're going to start with something simple like a retrieval augmented generation or a RAG or something like that, and you're querying data.
Yeah.
And then as you make sure your data is right and it's giving consistent answers back, then you're going to step up to the next kind of function or tool that you build into it. And it's you and I've talked. That's why I refer to them a lot as a really great interface for some of these other tools, because now humans can interact with them in natural language, but also there are times where I need the system to be 100% repeatable, so I can't trust an LLM to go do it.
Correct. I mean, the value of traditional models will always stay there, just compute-wise and predictability-wise. But LLM has its own place, I would say, right? So it's pretty good for prototyping something real fast, but to predict, like I'm probably preaching it multiple times. We got to build a whole suite of pipelines around it to make it really useful.
Cool. So, any closing thoughts?
Yeah, we'll have some more fun stuff next time. We have queued up some cool ideas for the next podcast.
And I think we're always welcome for anyone who's listening. If you've got other things that you would like to hear us talk about or things you'd like to see us demo or go into more in depth in, we're glad to do that. We had also been talking about conventional machine learning, so you're going to see us dive back into that and show both some conventional machine learning and how some of the new, over the next podcast, how some of the new multimodal LLMs or models are impacting that, and show where they're good and where we think that there are some things that you need to think about. And we're super excited and hope everyone's enjoying and having some fun.